Welcome to this video on introducing two-sample hypothesis testing. Let's begin. After watching this video, you should be able to state the differences between a one-sample and two-sample hypothesis test, and state the three types of two-sample hypothesis testing mentioned in this video. What is a two-sample hypothesis test? A two-sample hypothesis test, as the name suggests, compares two samples to each other. A two-sample hypothesis test attempts to determine whether the two samples could have come from a single population or whether there is sufficient evidence to suggest that they came from different populations. Recall that the purpose of performing a one-sample hypothesis test is to determine if a single population mean or proportion differs from a specific value. Let's compare that to the purpose of a two-sample hypothesis test, which is meant to determine if two means or two proportions from two different samples are significantly different from each other. The data structure of a one-sample hypothesis test is a single sample from one population. However, in two-sample hypothesis testing, as you might imagine, we have two different samples. The comparison in a one-sample hypothesis test is that we compare a sample mean or a sample proportion to a known population parameter. In a two-sample hypothesis test, we compare two sample means or proportions to each other. In a one-sample hypothesis test, the null hypothesis is that the population mean or proportion is equal to the hypothesized value. However, in a two-sample hypothesis test, the null hypothesis is that the means or proportions of the two populations are equal. So we need to add another layer when we start looking at our hypothesis test. So the first question we now have to ask ourselves is, how many samples are we being given? Are we being given one sample or two samples? I've already covered the decision matrix for one sample hypothesis testing. So let's just focus on two samples. So if we know that we have a two-sample hypothesis testing, we still have to ask the exact same question we asked with one-sample hypothesis testing, which is simply, what type of data are we being given? And just like one-sample hypothesis testing, we have two options. We either have categorical or qualitative data, meaning labels, or we have quantitative data, which is comprised of counts and measures. If we have categorical or qualitative data, then similar to the one-sample test, we will be collecting information about a proportion. So again, the population parameter is the population proportion. Conversely, if we have quantitative data, the population parameter is the population mean mu. So then you might think that we're done, right? We're finished doing our decisions. However, there's one extra piece of information, one decision that we have to make if we have quantitative data. And that is that we could have independent samples or dependent samples. So I've created a whole other video that explains the difference and how you know whether you have dependent or independent samples if you're working with quantitative data. This video is just to mention those three types of hypothesis testing with two samples. So again, you can either have two population proportions, you can have two population means with independent samples, or you can have two population means with dependent samples. So those are the three types of two-sample hypothesis testing. So let's look at the hypothesis statements involved in some of these hypothesis tests. So we remember from before, we know that if we have one proportion, our null hypothesis is going to be that the p is equal to some given value. Now, notice if we have two proportions, our null hypothesis is either that P1 is equal to P2, where P1 is the proportion from population 1, and P2 is the proportion from population 2. And note that we can algebraically rearrange this. If we subtract P2 from both sides, we can make this P1 minus P2 equals 0. And the reason I include both of these here, you'll see both of them in textbooks, and I believe, depending on what software program you use, a lot of times the software will say it as P1 minus P2 is equal to 0. To me, though, if you say P1 equals P2, that's the most transparent thing, right? We're saying that the proportion from the two populations is exactly the same. That makes the most sense to me. Okay, so then if we have one mean, as we know from previous learning, we should know that the null hypothesis is that mu is equal to some value that we're given. Okay, so now what if we have two means with independent samples? What is our null hypothesis going to look like? If you want, you can pause this video and make a guess. Well, it's almost identical to two proportions, right? Except for instead of the P1 equals P2, we have mu1 equals mu2. Again, saying that the mean of both populations is the same. And again, we algebraically rearrange this by saying the mean from population 1 minus the mean of population 2 is equal to 0. And this is what you tend to see in the software. So then this last case that I alluded to earlier is two means with dependent samples. And you might be tempted to think, shouldn't they have the same hypothesis statements? And unfortunately, they do not. So the null hypothesis associated with a hypothesis test for two means and dependent samples is mu sub d equals 0. And this mu sub d stands for the mean difference in the two populations. And again, I will make a whole video just on the difference between independent and dependent samples. Right now, the purpose of this video is just to expose you to this information and make you aware that there are 1, 2, 3 different types of hypothesis testing that we can perform with two samples. So now that you've watched this video, you should be able to state the differences between a one sample and two sample hypothesis test, and also state the three types of two sample hypothesis testing mentioned in this video.